Hello, chemists, and welcome to our next unit, which is looking at the properties of matter, something called the kinetic molecular theory, the way matter changes states, and then gets into gases. So this is a little break from stoichiometry. We're going in a different direction. And to start today, I just want to kind of explain how this is all going to be running, because obviously we're going to be going online longer than we initially thought. So make sure you pay attention to the Google Classroom and read all the instructions carefully. But basically, I'm going to post these lessons and little conversations. These are going to be short lessons to complement pages that I'm going to post from the booklet, other YouTube videos, and worksheets on the Google Classroom. Those will typically go up twice a week, the lessons and worksheets. Then we're going to spend the other days reviewing. And then on the last day of the week, we'll have a little assignment, which you'll submit to me electronically, and instructions will go up alongside that. This week, though, we have it a bit short, so we're going to do lessons on Monday and Tuesday, review a bunch of stuff on Wednesday, then have a little assignment on Thursday, all about the kinetic molecular theory and states of matter. So without further ado, I'm just going to briefly introduce these. There's also going to be notes posted that goes over these same topics, and you'll get a copy of this presentation. So it's up to you what works best for you and what you most like to interpret information from. You can use them all, you can use your favorite, you can use the internet, whatever you think is most helpful to you. But I recommend checking out these videos and doing the sheets that go alongside them as a starting point. For this presentation, there's a handout you have called like Lesson 1 questions. You can do that alongside this because we're going to go over pretty much everything it's asking throughout the course of this presentation. All right, so matter. What's the matter with it? Um, Matter is anything that takes up space and has mass. So that means it's something that exists and takes up space, which sounds so silly, but when you think about it, it makes sense. Like your glass of water, it has mass, so it has like molecules in it, and it takes up space. It fills your cup. We have like our water bottle or our cell phone. They have a mass. We can like weigh them on a scale even. They take up space, like in your pocket or on your desk, and they're made of matter. Also, as you would have learned about in past grades, we have gases floating all around us, and gases have mass as well, and they take up space, but they just kind of bounce everywhere and fill their entire container. But those are the two big points here. Matter has mass and takes up space. So, um, takes up space means it has volume. That's another way of saying that. So here we have like elements, compounds, and then we have homogeneous and heterogeneous mixtures. Don't worry too much about that for today. We're just going to keep on going. You can read over this if you like, but it's just going over different types of matter. Elements, compounds, mixtures that are all the same, or mixtures that are different, like a salad. Physical properties, when we're speaking of matter, are very important. That's really how we define matter. They're traits that can be observed or measured without changing the original composition. So that means while you have a phone as a phone, or a rock as a rock, without like burning it or smashing it, or like setting it on fire or cooling it down or whatever, these are things that we can observe. So we have things like mass, volume, energy, state, melting point, malleability, like how easy it can bend, solubility, how easy it can dissolve in water, or another thing, temperature, conductivity, luster, and you'll see all these words here. We have extensive and intensive. So extensive is dependent on the amount of matter. This makes sense because if we have more rocks, or like a bigger rock, it's going to have more mass. But it can also be intensive, which means it's just based on what it is. So the melting point of gold will be the same if you have 1 block of gold or 1,000,000 blocks of gold. Those are things that are just characteristic of the type of matter, but don't change with amount. So the only things that change with amount are how heavy they are, how much space they take up, and how much energy they have. The other things like their state, their melting point, their malleability, solubility, temperature, conductivity, and luster, and so forth, those don't matter on the amount, they matter on the type. I think there's a bigger definition about this in the notes as well, but basically what I want you to take away here is that matter has properties, and extensive properties depend on the amount of matter, and intensive properties depend only on the type of matter. I recommend too, as I'm explaining these, pause on each slide as you fill in the questions, or if you want to read them or copy stuff down to your notes, Think about this as like a moving PowerPoint that you get to pause at your own pace. So cut me off, pause me at any time you just want to read closer or take a look or write stuff down. I want to keep these videos short so they're like uploadable and you can find the information you need. But again, feel free to pause these at any moment and take a closer look. Okay, so here are our physical properties again, and the two words that we're going to introduce, or that you may have seen before, are qualitative and quantitative. So each one of these properties can be observed or measured. Things that are qualitative are things you observe. Like you just look to see if something's a solid or a liquid. You don't measure it or weigh it to see if it's a solid or a liquid. Same with how easy it is to bend. You just try bending it. You wouldn't measure it on a scale or anything like that. Quantitative are things that we need to measure to get a number for. So like mass would be kilograms, energy in joules. We'd use a thermometer for melting point. These are things with numbers. So quality is qualitative. Think quality, the qualities of something. And quantities are quantitative. So think a number there. So we're going to talk about properties of matter, and then they can be qualitative or quantitative, extensive or intensive. Those are just words that are good to know and have as vocabulary for this unit. So take a second here and read this over if you like. You don't need to memorize all these, like just by looking at them. Most of them just kind of make sense. Like if you just think about it, we're gonna measure temperature with a thermometer, so we get a number, but we're not gonna measure if something's a solid or a gas with a thermometer. We'll just look and take a look at it. Here's something that's illustrated called diffusion. It's a nice little GIF here. There's also a page in your notes on diffusion, which I've attached and should be in your booklet as well. But diffusion is something that you probably understand intuitively, and it goes a long way to explain what we're talking about when we talk about kinetic energy. Think about if you spray a bottle of Axe in a change room, if anyone's experienced that, like some body spray or some really strong perfume or some Febreze, something that travels. It can get sprayed at one side of the room, and then in a couple seconds it'll be everywhere, and you won't be able to escape it. And that's what we mean by diffusion. These particles are going to spread out evenly within their container, like whether that be a room or a bottle or whatever. Diffusion is the physical property, which is the ability of a substance to spread out or move through another. So when we're talking about diffusion, we're often going to talk about gases, but I just think this is an important visual to keep in mind before we really talk about states, just about how gases are able to move and spread out. And that is called diffusion. So a little qualifier here. The less attraction and or more energy the particles have, the easier it is to diffuse. So this is saying if these molecules aren't held together as strongly, they'll come apart easier, or if they're moving faster, they have more energy, then they'll also come apart easier than if they were very attracted and moving slowly. This is a good segue into states because the whole idea of solid, liquid, and gas is just about attraction and energy. Think about water. It can be a solid, liquid, or gas, and all that changes is its temperature. If you think about taking ice and heating it up to melt it, then heating it up even more to boil it. So gases diffuse easier than liquids, which diffuse easier than solids. Here's a nice little GIF and like moving around image of a solid, a liquid, and a gas. Let's take a look at how we can explain these. A lot of these points are very intuitive to you as a human being who is able to relate to what a solid is and a liquid is and a gas. But when we think about it just in chemistry terms, the definitions become a bit different than what you say. You might say, hey, your desk is solid, and like bang on it and see how that sounds. And you might know, hey, this tea I'm drinking is liquid. And you might know that, hey, I'm breathing in oxygen gas. But we're going to really look at these in a sense of molecules and their movement. So kinetic molecular theory. Kinetic means movement. Molecular means molecules, and theory means like our scientific approach. And that's how we're going to define it. So we'll see here. Solids are hard to compress with high densities because their molecules are very close together and they're not moving very much. They have a definite shape and volume, and they're not easy to diffuse. Liquids are hard to compress and less dense than solids. No fixed shape, but definite volume, so they take the shape of their container, you may have heard. and they're fairly easy to diffuse. If you think about if you put like Kool-Aid or like Crystal Light or like a Mio squirt into a bottle of water, it'll quickly spread out and diffuse to fill the entire like rest of the water. Whereas if you put a sugar cube in, it would take a lot longer. Then gases are easily compressed with low densities, have no fixed shape and no fixed volume, and they're very easy to diffuse. Think about when someone lets out a stinky fart. I know that's a bad example, but kind of gets the point across. It diffuses very easily, and people can smell it across the room. Physical change is something we're going to get into over the course of the next couple weeks. And a change in shape or state of a substance is crushing, cutting, folding, smashing, melting, boiling. These are things that aren't chemical reactions. We've learned about chemical reactions. That's when something changes from one compound to another. A physical change is when something changes its physical form but stays the same chemically. So think about how water and ice are both H2O, but they have quite different properties. We're not changing like water into hydroxide or something. It's still water. It's just going to have a difference physically. So a change in what it looks like, not what it is. That's what a physical change is compared to a chemical change. Physical change involves change in energy. They can be exothermic or endothermic. These words you probably would have heard during your chemical reaction time, but they're going to come into play here. Exothermic means energy is released. Exo, meaning like outside, think of an exoskeleton or something. Then endothermic means energy is absorbed, energy is coming in. Um, that means that you're going to have to put in heat. An example here that we'll look at more next week is if you're melting something, energy is going to be required because you're going to have to put in energy to make it melt. Like you'd have to microwave something to melt it. Whereas energy is released if you have to cool something down. We're going to look more at this later, so don't worry about it too much now. Um, Anyways, that's the end of our little lesson for today. I'd like you to just read all the notes that I post and try the worksheets alongside. We're going to look more at this actual kinetic molecular theory thing and the movement of molecules tomorrow. But for now, I just want you to recognize that solids, liquids, gases, and plasmas are all made of molecules, and they all move at different energies and have different attractions to each other, but they're still made of the same stuff. And just to end off today, I'm just going to briefly talk about plasma. Plasma is a force-state made of heated gas that is ionized into positive ions and electrons. So plasma is just really, 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 really hot ionized gas. Actually, a lot of plasma exists in like space and stuff. We're not going to focus as much on plasma. We're going to mainly focus on solid, liquid, and gas. But if you're interested, look into plasma in the notes and online. It's quite interesting. But it's just very, very energetic and ionized gas. You can see here, if we start at cool, solid, we get to the hottest, which would be plasmas. Anyways, thank you, chemists. Again, pay attention to the Google Classroom every day. And please feel free to email me with any questions and keep posted. Anyways, hope you all have a lovely day.